Hey everyone, welcome back. Ready to dive deep into something seriously fascinating. Today, we're tackling organ crosstalk during sepsis. And don't worry, we're sticking with you every step of the way to break it all down. We're taking our cues from some cutting-edge research straight from the annals of intensive care, so you know it's going to be good.
It's pretty amazing when you think about it. This research really shows just how interconnected our body really is.
Right, like we talk about the body as this kind of well-oiled machine, but it's more like a network, right?
Absolutely. It's like all these different systems constantly talking, working together. We call that balance homeostasis.
Homeostasis. Okay, so that's like our body's baseline, everything running smoothly.
Yeah, and that communication, it's so important, especially when things go haywire, like with sepsis.
So sepsis, for anyone who's not familiar, it's more than just an infection, right?
Right, it's your body's own immune response going into overdrive. Think of it like instead of just sending a couple of firefighters to put out a small fire, it's like the whole city's emergency response team shows up.
Whoa. Okay, that's intense.
Right. And sometimes that extreme response can actually cause more harm than the initial problem. It's not just about fighting the infection itself, it's about the body's reaction and how that can spiral.
So it's not just putting out the fire, it's about making sure the firefighters don't accidentally demolish the whole block in the process.
Exactly. And to regain control, your body has to make some major adjustments, like literally how it creates energy.
Oh, really? A metabolic shift? What does that even mean? Like, our metabolism changes when we have sepsis.
Yeah. Normally, your body prefers this process called oxidative phosphorylation. It's efficient, sustainable, but then sepsis hits.
Mm.
Your body's like, nope, we need energy fast, and switches to glycolysis. Less efficient, but way faster. It's like trading a fuel-efficient car for a gas-guzzling race car.
Okay, I'm starting to see the problem here. Short-term solution, but not great for long haul.
Exactly. And this switch can be especially hard on your organs. They need that steady, reliable energy.
So we've got this massive inflammatory response and energy crisis, and our poor organs are caught in the middle. How does the body even begin to get a handle on this?
It's a constant balancing act. Your body is always trying to regulate that inflammation. Think of it like a seesaw.
Okay, I like where this is going.
On one side, you have hyperinflammation. That's the initial all-out attack. But then, to stop things from going too far, the other side kicks in, trying to dial it back.
So too much of either side and the whole thing goes off balance.
Exactly. And that's when we see complications, organ dysfunction, the whole 9 yards. It's not just one organ failing in isolation. It's about the ripple effects throughout the entire system.
This is why understanding how these organs talk to each other is so important. All right, so we've got the stage set, the players are in place, but how does this actually play out in our bodies? That's what we're going to explore as we keep going. All right, so we've got inflammation going haywire, this energy crisis, organs caught in the crossfire. Where do we even start to untangle how this impacts specific organ systems?
It's helpful to picture our organs. Like, well, imagine these bustling cities, each with its own special job to do. And they're all connected, right? These intricate networks like transportation systems, but instead of cars and trains, think hormones and metabolites zipping back and forth.
So if one of these cities hits a major traffic jam, the whole network feels the impact.
Exactly. And some cities, they're practically inseparable, like the heart, lungs, and kidneys. They're constantly working together just to keep us going.
Yeah, you can't really talk about one without the others. They're like the ultimate team players. The heart pumps oxygen-rich blood to the lungs, then the lungs send that revitalized blood back to the heart so it can be pumped out to the rest of the body.
And of course, don't forget the kidneys. They're filtering waste products from that blood, making sure everything stays balanced. It's a nonstop loop, this incredible dance.
A dance that can get thrown off beat pretty quickly when sepsis hits, right? Like, what happens to this finely tuned system when one of those organs starts to struggle?
It's like a domino effect. One thing leads to another. Let's take acute kidney injury, AKI, as an example.
AKI, so that's when the kidneys can't filter waste from the blood effectively. What happens then? Does the whole system just shut down?
Not a complete shutdown, but it's definitely a critical situation. See, AKI isn't just about the kidneys themselves. It can trigger this chain reaction that impacts the heart and lungs too.
Hold on, how does something going on with the kidneys impact the heart and lungs? They seem so separate.
Well, that's the thing about organ crosstalk. What affects one affects them all. When the kidneys can't keep up with filtering, it throws off the fluid balance in the body. This can cause fluid buildup in the lungs, making it harder to breathe. And when the lungs struggle, guess what? The heart has to work harder to get that blood flowing properly, putting extra strain on it.
So it really is like that traffic jam. One little backup throws the entire system out of whack.
And this interconnected dysfunction is actually why we see something called cardiorenal syndrome. It's a serious condition where heart problems and kidney problems become all tangled up, each one making the other worse.
It's like they're stuck in this dangerous dance, each step making it harder and harder to regain their balance.
It highlights just how important it is to look at the whole picture, not just treat one organ in isolation.
Right, because treating just one part of the system is like trying to fix a broken clock by just focusing on one gear. You need to understand the whole mechanism. So we've explored this intricate connection between the heart, lungs, and kidneys. But what about those other players, like the other cities in this vast network within our bodies? Where do they fit into the sepsis story?
Well, next, we're going to journey into the gut microbiome liver-brain axis. It's this whole network, and it plays a huge role in our overall health, and it gets hit hard during sepsis.
The gut microbiome. Everyone's talking about the gut these days. It's like we're just starting to understand this whole ecosystem of bacteria living in our digestive system.
And it's not just about digestion. The gut microbiome, it's connected to everything, our immunity, even our mental health. And sepsis. Sepsis throws it all out of whack.
Okay, so how does sepsis mess with this inner world, this microbiome?
One way is something called leaky gut. Basically, the lining of your gut, which is supposed to be this tight barrier, it becomes more permeable. Like imagine a net with holes in it.
Leaky gut. That doesn't sound good. What's actually going on there?
It means stuff that should stay in your digestive tract starts leaking out into the bloodstream. And not good stuff either. Toxins, inflammatory molecules, bacteria, all things that cause even more problems.
Oh, so now they can travel anywhere in the body, wreaking havoc everywhere they go.
Exactly. And one organ that takes a major hit is the liver. It's like the body's filter, trying to clean up that mess.
But if the liver is overwhelmed, it can't do its job properly. It's like the city's waste treatment plant working overtime, and eventually it just can't keep up.
And remember, we're talking about the gut microbiome liver-brain axis, so the brain is part of this too.
Right. How does all this affect our brain, especially during sepsis?
It's a question researchers are still figuring out, but there's definitely a connection. The gut and brain are constantly talking, sending signals back and forth. And when sepsis messes with that communication, it can have some serious consequences.
So, like, sometimes people experience brain fog or confusion when they're sick. Could that be linked to this gut-brain connection going haywire?
It's a definite possibility. And it just goes to show that sepsis isn't just a physical thing, it affects our minds too. But we can't forget about those other systems that often get overlooked. Adipose tissue, muscle, bone. They might not seem as exciting as the heart or brain, but they're crucial too.
Okay, so we've talked about the heart, lungs, and kidneys, this intense dance they do, and then the gut, the liver, the brain, all these intricate conversations happening. But we can't forget about these other players, right? Adipose tissue, muscle, bone. They're kind of like the unsung heroes working behind the scenes.
They really are. They don't always get the spotlight, but they're absolutely essential. Like adipose tissue, we think of it as fat, but it's not just about storing energy. It releases hormones, influences inflammation. It's a busy system.
Right, it's not just sitting there doing nothing. And muscle, obviously, that's movement, but it's also part of regulating our metabolism. And bone, well, that's the framework that holds us up.
Exactly. And bone is constantly being broken down and rebuilt. It's a very dynamic process. And it's all influenced by hormones, by inflammation. It's all connected.
It's amazing how we often think about these systems as separate, but they're all part of this big conversation, this intricate web. So when sepsis disrupts everything, what happens to these often overlooked systems? Like what happens to our muscles and bones when our body is dealing with this massive inflammatory response?
One of the things we see is muscle wasting and bone loss. And it's not just from being laid up in a hospital bed, although that can contribute, of course, but it's also about the signals, the communication that gets disrupted during sepsis.
Right, because we were talking about those messengers, those hormones that keep everything running smoothly.
Right, and when sepsis hits, those signals get scrambled. Suddenly, the body's priorities shift, and muscle maintenance, bone health, they kind of get put on the back burner.
Wow, so it's not just the infection itself, but the body's response, the inflammation that can contribute to muscle wasting and bone loss.
Exactly. It's like all the body's resources are directed toward fighting the infection, and other systems pay the price. And the longer this goes on, the more pronounced those effects can become.
It really emphasizes that sepsis is a whole body disease. It affects everything. So how do we take all this information, this understanding of how everything is connected, and actually use it to improve treatments for sepsis?
That's the million-dollar question. I- It's one thing to understand the science, but how do we translate that into something that can help people in a practical way?
Well, imagine being able to actually listen in on the conversations happening between your organs during sepsis.
Listen in. Think of it like this. What if we could decode the language of those chemical messengers? Figure out which signals are messed up, which conversations have gone silent.
Like, we need a translator for this complex communication system. Can we actually do that?
We can. And that's where metabolomics comes in. It's basically the study of all these tiny molecules, metabolites, that are in our cells, our tissues, our fluids.
So instead of just seeing the symptoms, like, oh, this organ is failing, we could potentially see the early warning signs, the subtle changes happening at the molecular level before things get really bad.
Exactly. It's like catching those whispers of trouble before they turn into a full-blown shouting match. And that early detection, that's key, because the earlier we can intervene, the better the chances of preventing organ damage and saving lives.
Early detection is crucial for any disease, but especially for something as serious as sepsis. It's like you said, it moves fast. Are there other ways this idea of organ crosstalk is shaping the future of treatment?
Absolutely. Imagine a world where we're not just treating sepsis with broad-spectrum antibiotics and hoping for the best. What if we could create personalized therapies? Treatments tailored to an individual's specific organ crosstalk profile.
So instead of a one-size-fits-all approach, we're talking about really targeted therapies that address the specific breakdowns happening in that person's body.
Precisely. If we understand which signals are disrupted and where, then we can develop drugs that correct those specific imbalances. It's like fine-tuning an orchestra to make sure the symphony plays on.
This is really incredible stuff. It sounds like a lot of this is still in the research phase, though. What can we take away from all this right now? Like, what's the key takeaway for our listeners?
You're right. These kinds of breakthroughs take time, and research is ongoing. But I think even just knowing about organ crosstalk, it changes how we think about sepsis. It highlights how interconnected our bodies are.
It's about seeing the bigger picture, right? We're not just a collection of individual parts. We're this incredibly complex system, and everything is linked.
Exactly. And who knows, maybe one of our listeners will be the one to make the next breakthrough in this field.
I love it. So for everyone listening, remember, knowledge is power. Learning about this stuff, sharing what you've learned, supporting research, it all makes a difference. The human body is amazing, and by understanding how it works, we can help it heal.
There's so much more to learn about organ crosstalk, and this is just the beginning.
That's a wrap on another deep dive. Until next time, stay curious.